Okay, well, it's a great pleasure to welcome you to this second panel of the afternoon. And the title of our panel is The New Space Industrial Ecosystem. And what we want to explore together in this panel is the current state, but also the future evolution of space from an industry and government perspective. And so this includes the latest trends that we see, and then the challenges also. And the central question, really, I think that we want to discuss together is whether we are headed toward a self-sustaining industrial ecosystem in space, or whether it's much further out, or perhaps that has already emerged and not everybody is aware. So we have a distinguished panel here with senior leaders from world-class organizations that are actually designing, launching, and operating the most advanced space systems in existence today. So to get us going, let's take a look at some of the key milestones in the development of space capabilities, close but also far away from Earth, that have happened in recent years. So 1981, the first flight of the space shuttle, STS. 1990, the first air launch of Pegasus, Orbital Sciences. 1996, the launch of the Mars Pathfinder mission, JPL. 1998, the initial module launched for the International Space Station. 2006, Spheres, the satellites developed here at MIT together with Aurora Flight Sciences on the ISS. 2010, the first launch of the Falcon 9 by SpaceX. 2012, the landing of the Mars Curiosity rover at Gale Crater on Mars, and Maria Zuber showed us a lot of data from that mission before lunch. 2013, commercial ISS resupply services started with the Cygnus by Orbital ATK. 2015, the first suborbital flight of New Shepard by Blue Origin. And very recently, 2018, the first Block 3 GPS satellites launched by Lockheed Martin. So a quick look at this list should dispel any notion that things have slowed down since the glory days of Apollo. A more quantitative view shows us, looking specifically here at the population of satellites, not in geosynchronous, but in low Earth orbit and medium Earth orbit, so-called distributed satellite missions, shows, so this is where two or more satellites are collaborating together for different mission objectives. So we see that from the 1960s to the 1990s, and this is the purple shaded curve, intelligence and surveillance satellites were really the dominant species of satellites that we launched. And then there was a crossover in the 1990s. You can see a big step in that blue curve, the second highest curve here. And that big step was the launch of the first generation of satellite constellations, ORBCOMM, Iridium, Globalstar. And so the telecommunication satellites really became the dominant species of satellites. And then we cannot help but notice the green curve, which is the one showing a very sharp rise since 2015, and those are remote sensing Earth observation satellites. So something new and fundamentally different seems to be happening here. So with that, I'd like to introduce our panelists. So to my left, to your right, we have Dr. Keoki Jackson. He's the Chief Technology Officer of Lockheed Martin, where he's responsible for the corporation's advanced technology strategy. Dr. Jackson's previous role includes Vice President for Navigation Systems and Program Manager of the Global Positioning System, the GPS Block 3, which is shown here. And before Lockheed Martin, Dr. Jackson was a NASA Research Fellow in the field of human adaptation to the space environment. He received bachelor's, master's, and doctoral degrees in aeronautics and astronautics from MIT, and that makes you MIT cubed, I guess. As we like to say. And next, we have Larry James. Larry James, who's the Deputy Director at JPL, the Jet Propulsion Laboratory, where he's responsible for the laboratory's solar system exploration, Mars, astronomy, physics, Earth science, interplanetary network programs, and all of the business operations of the laboratory. Prior to his retirement from the Air Force as a lieutenant general, James was the Air Force Deputy Chief of Staff for Intelligence, Surveillance, and Reconnaissance at the Pentagon. He received his Bachelor of Science degree in astronautical engineering from the U.S. Air Force Academy, a Master of Science in Aeronautics and Astronautics from MIT, and where he was also a Draper Fellow. Next, we welcome John Langford. Dr. John Langford is the president and CEO of Aurora Flight Sciences, which he founded in 1989 in order to design and manufacture high-altitude UAVs for global climate change monitoring and research. John received his PhD from MIT in the field of aeronautics and also public policy. He also received a bachelor's and master's degree in AeroAstro and a Master of Science in Defense Policy and Arms Control from MIT. John managed the MIT Daedalus human-powered aircraft project, which still today holds official FAI world records for total distance, straight-line distance, and duration for human-powered flight. In April 2017, John Langford was elected as president of AIAA. Dr. Bob Smith is CEO of Blue Origin, LLC, a private company which develops rockets to enable human space exploration. He's a fellow of the Royal Aeronautical Society, and Bob was previously president of Mechanical Systems and Components and CTO at Honeywell Aerospace. He left Honeywell in September of 2017 to join Blue Origin. And during his tenure before at United Space Alliance from 2000 to 2004, Bob was executive director of the Space Shuttle Upgrades Development Program. He holds a master's degree in applied mathematics and engineering from Brown University, a PhD in aerospace engineering from the University of Texas at Austin, as well as a master's in engineering and management from MIT. And last but not least, David Thompson. David Thompson is the co-founder of Orbital ATK, now known as Northrop Grumman Innovation Systems, and recently retired as its CEO and president. He co-founded Orbital Sciences Corporation in 1982, and he was previously at Hughes Electronics Corporation, NASA Marshall Space Flight Center, and Draper Laboratory, where he worked on the space shuttle's autopilot design at Draper. As a past president of AIAA, he was elected to the U.S. National Academy of Engineering. He received his Bachelor's of Science in AeroAstro from MIT, his Master's in Aeronautics from Caltech, Dave will forgive you that, and an MBA from the Harvard Business School. So please give a warm welcome to our panelists. So I'd like to start with a first question, really for all our panelists. And the first question is simply, what do you see as the key contribution and perhaps the key challenge also for your organization in this age of new space? So Dave, if you want to start off.
Okay, well, in my case, this will be, I'll put it in recent past tense, since I'm kind of semi-retired these days. I'd say over an almost 4-decade period, my colleagues and I established and built the world's first space systems manufacturing company that was created after the launch of the first Sputniks that reached Fortune 500 status last year. And as a very important part of that, I think we were one of the pioneers of using commercial business models in the space sector. As to challenges, I think for many years, the biggest one that we faced, or I faced, was not finding really interesting ideas because engineers generally, and certainly space engineers in particular, are full of those. But ideas that would have a good probability of forming businesses that could earn at least their cost of investment capital, which is a little harder problem.
Mm-hmm. Great, thank you. Bob.
So for Blue Origin's a startup. You should think about it as a large startup that is startup nevertheless. When you start up any business, you should look at what your customers' values and what they would value over a long period of time, and start from there and work backwards. So in commercial retail, and general retail, what you look for when you go to a store is high availability, low prices, and great customer service. That's what you always want. You will always, always, always want that. You won't have a day in which you go, I'd like to pay more for that. I'd like worse service. So what Amazon did is they actually did that through e-commerce. They said, I can get all of those things. Lower prices because I get bigger scale. I get better customer service because I drop it off at your door. And I get great availability because you can sit, look at all the things that are online. Space has the same problem, meaning that it needs some things that customers will always, always want. They will always want low-cost launches. They will always want to go whenever they want to go. And they want to make sure that it's safe and reliable every time. So in a similar way, Blue Origin is committed to really doing operational reusability, doing it time and time again, because that tool gives you those kind of attributes. You get low price, because you're not throwing away a bunch of your hardware. Obviously, because you have a well-characterized, established system, you get to fly it often, because you now know what that looks like. And then obviously, because you have to get the robustness and margin and fault tolerance, you're going to be able to actually go do that safely and reliably, more so than you would in an expendable system. So those operational characteristics are what we're working for. We're making sure that we have an operationally reusable vehicle. What you see behind us is New Shepard that we've now flown now over 10 times and getting ready for our next flight. We're going to fly humans on it this year. An exciting avenue, but people that don't recognize that's nearly 100% reusable vehicle. Everything on there gets reused. And so we fly that with roughly about 30 people. We go to space in about 12 hours from the time we go from the processing vehicle out to space and back. And we do it routinely at human spaceflight standards. And that's what we're working on to really get operational reusability into what we do every day and what we do for our orbital vehicle as well, which we're building called New Glenn. And that's part of fundamentally what we're doing. We're committed to that operational reuse idea. The biggest challenge that we have is the challenge that a lot of startups have, which is just scaling up. We've gone from a small research organization now to having multiple facilities and multiple sites, building a new launch pad, and hiring like crazy, which is a good problem to have, actually.
Great.
So in terms of Aurora, we're sort of the aero representative on the stage as well as the space side. The picture is the Spheres satellites that we did in collaboration with the aero department here. I would say our biggest contribution is summarized in one word, and that's autonomy, right? The focus of what we are fortunate enough to be participating in is this revolution in aviation as well as in space that's driven by the characteristics of autonomy. And in our particular field, over the course of the 30 or so years we've been in business, we've gone from the unmanned aircraft, where you take a pilot out of the cockpit and move them to a ground station on somewhere else on the planet. And then now what's going on is the revolution where autonomy is removing the pilot from the ground station and moving the command and control of vehicles into a network type of configuration. And that autonomy is enabling real revolutions across a whole range. You've already seen it, first in the military domain. You've seen it in the commercial domain, what's happened where we went from radio-controlled helicopters being one of the hardest things to fly to literally having millions of small drones in the national airspace, but now into things like autonomous air vehicles that will be safe enough to carry people, to very long endurance platforms, pseudo-satellites that can stay on station for months in the stratosphere, autonomous freighters that can move cargo, and so on. And so that's a real revolution in aeronautics and of course is applied in space as well.
The challenge I think that we face is talent, I would say, and talent with a particular emphasis on diversity. I mean, just look at this panel. This is not a testament for diversity in our business. And as we move into autonomy, the talent competition is not just between those of us sitting on the stage. We compete now in the things that underlie these new revolutions in aeronautics and space, in autonomy. Those are computer science tasks. Those are artificial intelligence, machine learning. We are competing with the tech companies. We are competing with every automotive company in the world. And so each of our organizations is working to reform itself. This is something that the Aero department itself faces. It's an industry-wide challenge. We see it in the AIAA. As we move from the sort of brigade technologies, as we call them, the traditional disciplines, structures, propulsion, fluids that we all grew up with, and incorporate the new technologies that are really driving these revolutions of computer science, machine learning, AI.
Great, thanks, John. And I hope you will all stay for the student panel, or the student lightning talks, because it will give you a lot of hope, I think, for the pipeline that you talked about. Please, Larry.
Okay, well, JPL sets it kind of an interesting juxtaposition with industry, because we are not an industry or industrial organization. We're a federally funded research and development center. We're NASA's FFRDC. So part of our charter really is to take on those technological challenges that NASA gives us and figure out how do we solve them in order to answer the science questions that we've been given, the very hard science questions, but also to transfer that technology to industry. I mean, that's part of our charter as an FFRDC. And we take that very seriously. I think you talked about being a startup. We like to say we're a 60-year-old startup. I don't know if that's possible, but we try to maintain that kind of thinking in what we do. And so as you look at the contributions, I think as you look at the missions, you see the Curiosity rover there. And really part of our mission is to figure out how do we do these things in a very autonomous manner. How do we do these things robotically in extreme environments where you have no human in the loop? And I think certainly those are the types of technologies that help to spin off into other capabilities that we all have to have as we move to the future, especially in this more autonomous world. I think too that when you think about JPL, you often think about these big missions. But the reality is that we also are figuring out in this day and age with miniaturization of electronics, what can you do with the smaller spacecraft? And it kind of gets to the cost equation, which if we can start putting smaller things on orbit that can actually do missions, and you heard Sarah Seeger talk about Asteria and the ability to point a CubeSat very accurately to do exoplanets, that's an area that we're really delving into pretty deeply. You may have seen that we had the first interplanetary CubeSats with the Marco spacecraft that went out with InSight that landed on Mars in November. And so really taking that technology, that miniaturization, and the ability to do actual missions with it is where I think we also contribute to the community writ large. Another example is we developed the first Ka-band radar CubeSat. And it's doing science. It's Ka-band, it's detecting precipitation formation inside a cloud. And that's something the scientists can't see without that type of radar. And with multiple CubeSats, you can start to get time-phased pictures of how precipitation is now forming in a cloud. So I think those are some key areas: robotics, autonomy, miniaturization, and allowing us to do actual missions at a low cost that ultimately we want to infuse into the community. And the last thing is sensors. I just have to say this: we're developing superconducting nanowire single photon detectors. So say that quickly, but you know, when you're talking about finding exoplanets, these will be probably the most sensitive detectors ever created, if we can pull it off. And so again, that has a whole host of potential capabilities that industry can use. Challenges, I think for us, it's system complexity. As you go from, for example, Curiosity to Mars 2020, to a sampling system that has to cache samples autonomously, keep them isolated, ultimately put them in a retrieval vessel and bring them back to Earth, all without human interference. And then just the systems engineering to do all of that, and the tools that are now becoming available, how you integrate all of that into these incredibly complex and connected systems is a challenge I think we all face and that we're certainly trying to work towards. So thank you.
Thank you, Larry. And Keoki.
Okay, well, maybe I'll preface my remarks with a couple of things. One is, when you talk about new space, having been in the business like these folks for 30 years plus, I will say it is new every day, and it is really an incredibly exciting time now and has been. The other thing I'd say, when I talk about what Lockheed Martin is most proud of, we got to remember this is very much a team sport, and so Lockheed Martin has been in support of Larry and his job before JPL, and of course at JPL and NASA, and worked with I think everybody on the stage here in one way or another, and so that's something to be proud of in and of itself. The thing that I look at for Lockheed Martin, say we're most proud of, is we've made space a taken for granted part of everyday life. And so think about, you get up in the morning and you put on the Weather Channel, or maybe hit your weather app, and that's fed by a GOES-R spacecraft. Then you might do a little bit of online banking or something like that, and that's all driven by timing signals from the GPS constellation. And you hop in an Uber or a Lyft, and all applications that are completely enabled by GPS. And this is all pretty much before you have a cup of coffee in the morning. So, and you don't think about it, right? But that is the impact that space has had on our everyday life, and that's what Lockheed Martin has been privileged to be a part of in a lot of ways. The other thing I'd note, we talk about a sustaining space ecosystem, and there are a lot of big visions out there, and think cislunar space and the opportunities. Now, Lockheed Martin, our belief is that this will happen. It's a little bit hard to say when. I think we'll talk about that, but it's not going to happen without the exploration capabilities that come before the kinds of things that Larry talked about, and so Lockheed Martin is very proud to have been, for example, part of pretty much every Mars mission the U.S. has ever done. Of course, Mars Insight there now. We're around Bennu and mapping that asteroid and starting to get back pretty interesting science results there. And of course, Orion, which is the only really deep space ready exploration vehicle that the U.S. has got. I'd say the world has got. And so we're very proud that we're a part of doing that front exploration that will enable that future ecosystem.
Great. So we would like also now to get everybody involved. So please, if you have a question for our panelists, there are some cards circulating. Hold up your hand. You'll get an index card. If you like the old way, if you like the new way, just please go to your browser and submit a question to this link. So the second question is really for everybody, and that is this question of where is the space enterprise headed? We saw this morning, in fact, it's printed in the program. We see the notice of the first contract to MIT, to the instrumentation lab, to develop the guidance system. So we have depended on large government contracts to get us into space and to get the momentum that we see today. But can we look forward to a self-sustaining ecosystem where, Bob, maybe your primary customer is not the US government, but it's private citizens or it's another commercial entity. So is that realistic? Certainly it's happened in aviation. You know that aviation started by carrying the mail under government contracts, and now aviation, I think we would all agree, is absolutely a self-sustaining industry. So are we there already? Are we on our way, or is it an illusion?
Well, I'll start. So I think aviation is a good analog in some ways and not a good analog in another way. I would say that aviation, if you go track its history, is it started off, Wright brothers, who were their first customers, they went to the United States Army. And then they also went off to do airmail. The industry did broadly. About 25 years later, you had places like Lufthansa come in and start up real airline operations. But it took really some innovation around some aircraft, DC-3 being one, then going to, I think, really the Boeing 307, which was the first pressurized aircraft that got you above the chop of turbulence that makes everybody nervous about flying, and then getting to the de Havilland Comet, which was the first commercial aircraft in '52 that did jet service. That's when you really started seeing a break over into a true commercial environment where you actually got people from point to point in a way. So that was about 50 years. We flew about 4 billion people last year worldwide. So if you think about 100 years, roughly, from commercial service to 4 billion people, that's a big impact. But that arc looks somewhat familiar to where we are now, I think, with where we're going with overall space flight. So I think that looks about directionally correct. But I think the thing where it's dissimilar is that air travel took places that we knew and connected them. They were already well characterized. We already understood those environments. We already understood what was there. It made it quicker, it made it easier, it made it more convenient, but it was fundamentally the same places. I think the thing that's going to be very interesting is that space goes someplace different. It has different energy in terms of the solar power you get from the sun, has resources that we haven't tapped. We have, obviously, an environment that's very different. So I think the question that really is out there is that once you reduce that cost of launch, which we're really committed to doing, you can do all these into entrepreneurial experiments that now test out that environment, test out that energy source that's free. How do you actually do all those experiments? We all have been in this industry too long to have seen a lot of studies that sit on the shelf. And they sit on the shelf for really one fundamental reason. It costs too much to do the experiment. So if we actually get to the point where we can go do that, which I think we're on the cusp of doing, you're going to get more entrepreneurs coming up and testing that new environment. If you make the comparison to air travel had a huge economic value just connecting 2 points. If you add that to the fact that you're going to someplace different, it could be very exciting.
I'll jump in here. You know, it's interesting, the plot that you showed there and sort of the growth in these different constellations, and obviously ComSats are kind of up there at the top. And people might argue, well, that's really the only example that has, at least so far, really shown to be self-sustaining. But I'd argue that's really looking at the problem much too narrowly. And of course, I spent a fair amount of time on GPS, and that's very dear to my heart. But GPS creates about $70 billion worth of economic activity a year in the US alone, right? And obviously much bigger than that worldwide. And I think 2015 was the year that we crossed, in a sort of a very exponential curve, the first year that 1 billion GPS devices were delivered. And so if you think about that as the space economy, you might argue we're there in more ways than people have ever really thought about or even consider in their day-to-day life. So I'm pretty excited about that as an example because it shows you, what can happen exponentially when you come up with something that's truly enabling. From a Lockheed Martin perspective, we want to see this ecosystem take off, and so we've done some things. You think about it, there were something like 900 different space startups in the last, I think, about 5 years. So, right, that's a big number. Last year, about 2.9 billion in venture capital globally. A little more than half of that went to launch, actually, and some of that, and the next biggest fraction was in spacecraft. So far, I think we're still on that part of the curve that Dave talked about where we're investing but not seeing returns. But Lockheed Martin's absolutely, so we've invested in companies like Rocket Lab, companies like Terran Orbital or Tyvak to really try to drive some of that ecosystem as well. And we're doing things like open sourcing our ICDs for our satellites to be able to bring payloads on that might not have another opportunity. So if there's something innovative out there, make it meet the payload ICD and we can fly it. And example of that, I mean, Orion, of course, coming up here, we heard about Exploration Mission 1 earlier today, and we've gotten over 24 good proposals back to that ICD for that flight alone. And so that's just, I think, a real little taste of what that opportunity might look like. And so and we're going to continue to drive this through all of these, mentor-protege relationships, working with those hundreds of companies that are out there, and really try to enable the growth of that ecosystem from where it is today to a much more mature standpoint.
Ollie, let me add a couple things to that. I agree with a number of those points. According to a couple of industry research groups, the global space economy last year generated about $350 billion in measurable revenue. Using that fairly broad definition, and I'll talk about GPS in a minute. To put that in perspective, I think if you applied the same broad definition to the global aviation economy, you'd come up with a number north of $1 trillion. I don't know exactly, $1.25 trillion maybe, something like that, which would include aircraft manufacturing, operations, maintenance, and so on. So, the global space economy is pretty good size in a world, planetary product of 75 trillion or so. It's not negligible. I think there are two business models that make up that roughly $350 billion in space economic activity, and both private customers and government agencies are represented in those models. One is the one that's developed over the last 40 or 50 years, and that's the use of space systems essentially as photon factories that collect and process and transmit information of various types. The other and newer and I think more speculative one is space systems as matter factories. The matter might be human beings, it might be raw materials, it might be finished goods. And today, of that $350 billion or so, 99-point-something% is in the former category. And the story there is pretty impressive. To date, the world's largest space-based business is DirecTV, which is now a subsidiary of AT&T. And last year, that business generated about $30 billion in annual revenue, and it provides television and internet access to about 50 million people in the U.S. and many more throughout Latin America. It's such a compelling business that a couple of years ago, AT&T bought it for $67 billion. So it's pretty big. I think although that's probably the largest single space enterprise from a financial standpoint, I would agree that perhaps the largest somewhat commercial space business from a broader societal standpoint really revolves around GPS, the products and services that we've all come to take for granted. The current installed base of GPS-enabled devices as of the end of last year was about 6 billion, which means on average 80% of the population has one, and that's not the way it really works. 20% of the global population has several, and 80% really doesn't have anything. And then there's some other examples. So the business model of information collection, processing, and transmission has brought space into our homes. It's put space in our vehicles. It's put space capabilities in our pockets. And the way it's done that, the numbers are a little different if you're comparing commercial communication satellites to GPS products, but the themes are similar. There's been a because of innovation and competition in the technology and manufacturing sectors, we've seen pretty steady improvements in the key economic figures of merit over the last 35 or 40 years that have typically been in the 10 to 12% per year range. So imagine what happens when you compound 1.1 or 1.15 to the 35th power. You get on the order of 40 or 50-fold improvements. Now, if we'd done that in automobiles, we'd all be driving, cars today that got 700 miles per gallon. Well, it didn't happen in that area, but it happened here. So I think the real question is, and beyond the technology improvements, the service sectors have been innovative and market responsive in the ways that they've converted those improvements into tangible and affordable and market competitive benefits to a few billion people around the world, and we still have more billions to go. I think the key question as we look ahead over the next 25 or so years is, will the second business model really take off? The model where we use space systems to collect, to process, and to transport physical objects. And I think the jury's still out on that, whether that will itself generate substantial and sustainable space-based businesses. I just don't think it's knowable today, but you can do some back-of-the-envelope calculations that suggest it's not going to be easy.
Great. Thank you, Dave. So we have 60 questions, which we're not going to get to, but I do want to get a good sample of those. So maybe we have two quick statements on this self-sustaining, and then we'll go to a sort of rapid-fire mode. Is that okay?
Sure. Yes? I think the question you're really asking, Ali, in that is, does the paradigm that has existed in this country since about 1945, when Vannevar Bush laid it out in the post-war, where the U.S. government allied with universities and big corporations has driven the modern R&D enterprise, is that changing? I think the answer to that is no. I am a skeptic of the idea that model is now outdated. I think one of the things that you mentioned Daedalus early, looking back from the time of Daedalus to the time of everybody sitting on this stage, one of the fundamental human challenges has been how do you get support, financial support for creative enterprises? And that is the challenge that everybody has faced from Daedalus to Da Vinci to Michelangelo to von Braun to Jobs. And there are only a few models that have worked over time. And the Vannevar Bush model of the modern scientific industrial society is the one that we've all grown up in. I think you have seen some of that society produce enormous wealth from some government-aided things like the internet that has allowed individuals to do, with the progress of technology, to do what a few decades ago, it took a whole nation to do to launch somebody into space. And today it's within the realm of private enterprise, private fortunes. On the other hand, I would point out, look at winning the first private flight, winning the X Prize, 2003. You mentioned that the first passenger just flew last year. That's 16 years to do what NASA did for Alan Shepard in 3. Okay, so the idea that, private enterprise has this great thing that it can just beat the pants off the established model, I'm not sure the data actually supports that. I think what you do see is a lot of things where frustration with the procurement practices and the conservatism that has grown up in some of the government procurement systems has created some frustration, and people are trying to find ways to move faster, both inside the system and by going around it. I'm not sure the data fully supports that's as successful as some people would like to think it is.
Very good. So you're a skeptic. Good. Larry?
I just say two things. One, I think the keys are cost to get to space, and then the size of systems that you can put into space. And I think industry really is driving the cost down. And if an individual can pay $10,000 for a ticket to go into orbit, you change the total dynamic. And are we getting there? I don't know. But I think the cost is the key thing, and then if I can put something up there that is useful at a low cost, that also changes the dynamic. And I think we're on a path to potentially go down those paths.
Okay, great. So I think we're going to transition a bit and go to sort of rapid fire mode, if that's okay with you, because we have a lot of questions and some are quite controversial. So I'm going to put them out there. So first one, is it still worthwhile pursuing the SLS? This is the large launch vehicle, given the massive delays and ballooning costs of that program and the availability of commercial alternatives. There's actually several questions on SLS. Is it worthwhile pursuing that further?
I will say absolutely yes.
Talk to the prime contractors first.
So as from Boeing, yeah, absolutely. And I would say to everybody in the audience, if you get a chance to go to that launch, you absolutely should, because growing up and getting to go to a Saturn V launch was a pivotal part of my growth and development, and it affected everybody I knew who saw one. And the shuttle was impressive, not to put any knocks on that, but to have seen something in the Saturn V class go is amazing.
Okay.
Let me just one quick addition to that. You don't think about this often, but from a planetary perspective, it opens up the outer planets for exploration, because we're hoping to launch Europa mission on an SLS, which gets us there in about 2.7 years versus 7 years, which we have to use currently with today's boosters using gravity assist. So yeah, from a science perspective, you open up a whole new domain of rapid exploration of the outer planets with the SLS, and that's pretty exciting.
Yeah, I'd just add on to that. To me, it's not clear there is a commercial alternative, first of all. And second, I think Boeing would probably note that they are a commercial enterprise. I won't speak for them, but you know, you got to remember, these are for-profit companies that are out there doing this work.
I'd just add one thing, is that you need, if you build a bespoke government system, if you have sufficient bespoke government missions to go fly them on. And if there's enough demand there for SLS, then you should go build SLS. If not, you should do what you do on anything else. You go rely on the commercial alternatives available.
Okay. Another question is, a couple of you mentioned as a challenge hiring talent, young, passionate people. How do you compete with big tech for talent? We had a big career fair here a few weeks ago.
Sure.
And there's a lot of competition from other industries.
I think it's all about a sense of mission, right? I mean, I think what the kind of people who go into this industry are people who are passionate about what they do. I think there is a seductive quality that the tech companies have been able to build up, some of it with effective branding, quite honestly, some of it with amenities in the workplace. But ultimately, you only have a certain number of heartbeats. You want to spend them on things that really matter. And I think that's why most of us are in this room, because we believe in the importance of what we're doing.
And I would echo that, you know, we rely on the mission to excite people in terms of what we do. And that's a pretty easy sell. And then there's some strategies we use that we bring in 800 interns every summer. And if they're graduating the following summer, you can make them a job offer at the end of their internship. And they show up the next summer, and when Google comes knocking in November, they say, I've got a job at JPL already. So
Yeah.
got to be smart about how you do it, too.
Yeah.
Yeah.
I would just add on to that. First of all, we're hiring like crazy at Lockheed Martin, so if anybody out there is looking around for something really exciting to do, some of that I can talk about and some I can't, but it's all good. I agree on the mission front. I've had the opportunity to work on missions you know, that touch billions of people worldwide. I've had the opportunity, you heard from the Apollo group this morning and some of those experiences in mission control and on the spacecraft. I've had the opportunity to work those missions and have some of those sort of heart-stopping moments, most of which turned out well, a lot of them in places with, you know, that people don't talk about. But that is very much alive and well, and I see that in that joy of the mission and the folks that come and join us every day. I'll just give you an example. We held a Home for the Holidays recruiting event at Palmdale near the Skunk Works just this past Christmas time. And you know, they do some pretty cool stuff out there. We expected maybe a couple hundred people to show up. Over 1,000 people showed up, and that just gives you an idea of how passionate people still are about the world of aeronautics and space, and how exciting people find that.
Oh,
hire missionaries, not mercenaries. I mean, that's the short version. When you have people that come in and they're really looking for the boy, I really want to go catch the golden ring at a tech startup, they're not the right people for what they want. You want people that love this kind of work.
okay. Great, thank you. The next question will probably put you on the spot as well. And that's, there's an obvious omission on this panel, which is nobody from SpaceX. So many questions about SpaceX. For the record, we did invite SpaceX. They couldn't make it. So I'm going to summarize these questions. How do you think of SpaceX? Please.
How much time do you have?
Go for it, Bob.
So, I mean, first of all, you cannot deny they've done some remarkable things. I mean, this picture that you have up here is absolutely stunning. I think the world looked at that and was just amazed at the remarkable things that SpaceX has done. I believe that it is a good testament to what an entrepreneurial space company can go do. I think they're seeing what we can do differently in the space industry when we think about things differently. So I think that's encouraging a lot of people, and quite honestly, the economic pressure it put on the industry is good for everybody. We want that. We want that type of competition. We want that kind of drive because they are driving down launch cost, and that's good for everybody.
I guess I would just add, I agree with Bob. They have done some very impressive things from a technical and operational standpoint. Most of us at some point along the way were trained as engineers, and we love designing and building things. But from a business standpoint, we can't just focus on the supply side. We've got to think hard about the demand side of the equation. And if you've designed your system so it's only going to work from an economic standpoint if you're operating at a rate of 25 or 30 launches a year in a market that is going to allow you to capture 10 of those launches a year, over time you're going to have a problem. So I think we'll have to wait and see what the next 4 or 5 years brings. But technically, yeah, very impressive accomplishments.
I think what SpaceX represents to me is one of the biggest changes from the time I was at MIT, which is the growth of entrepreneurialism in the whole industry, right? That when we were coming up, it was, as Dave says, started out saying, there had not been a startup in this industry in decades, right? Before Dave launched Orbital. And today there is this massive resurgence, and MIT is right at the middle of it with all kinds of innovation activities, the sandbox and so on, that make it easy to start a new enterprise. And I think that is an incredibly positive change for the industry. It's part of what drives the vigor, the enthusiasm. That's what pulls talent into, the vitality of the collective enterprise is a huge thing.
SpaceX did a great job on that first GPS-3 satellite launch in December, so thumbs up there. I want to hark back to one thing John said. We should not neglect the critical role that the U.S. government, particularly NASA, the Air Force, and other agencies had in actually making SpaceX a viable enterprise there. And so I do want to, and that is not in any way to put down what SpaceX has done. And as a company that makes our living getting stuff in, from stuff that gets to space, right? We're very excited to have that option. But if you think about what the U.S. government is doing in terms of investments in the infrastructure for R&D, for the underpinnings for an aerospace business, we are eating our seed corn. We're living off of investments that were made decades ago. And you see that in things like wind tunnels. You see it in the state and condition of our national laboratories and NIST. And so I think that this is a model that the Chinese and others are looking at and copying today because they feel it hasn't gone out of date. And it's something that I think we got to pay attention to here in the U.S. to make sure we are investing in the infrastructure that is going to sustain that space world in the years to come.
And Keoki, that's actually a great transition. We just have time for maybe a couple more. And so I think you're the first one to mention China, and we have a number of questions about China. So is the United States positioned to remain the global leader in space? Yes or no? And specifically, is the competition with China effectively a new space race?
Yes and maybe yes.
Dave, do you want to?
Yes, and I think the thing that I would say relative to the race, it depends on what you mean by that. I think it is really fundamentally a contested environment that we're going into, meaning from a national security and overall effort. And so that's a place that will drive some measure of activity. The question is whether it's a competitive one or a collaborative one. I don't think we know yet.
And I think to your first question, yes. I mean, I think our government wants us to stay in the lead. I think on China, it is, I think, what sector are you looking at? I think they're not necessarily as competitive in the commercial sector of providing services. I think if you look in the defense and intelligence sector, that's where there's more of the competition, back to the contested, congested environment that yes, we have to deal with that.
I don't know if I would use the word race, but we are very definitely in a contest, and nobody should mistake that. And it's not just space, but it's the whole set of enabling technologies for what we are trying to do in space today, whether it's photons or matter or anything else. Is the U.S. poised to do well? I would say we have all the advantages. And if we don't, shame on us. But I'm looking forward to the panel that's coming after us here, but looking around the room here, I would say the folks that we have to look to in the years to come make that a very good possibility that we're going to do extremely well.
Thank you.
I would just say the Apollo program that we've talked about today and that we're all celebrating here today was clearly driven by great power competition. Would not have happened without the great power competition. And, you know, who's to say that competition isn't a good thing sometimes? Yeah. We clearly are being challenged to up our game in this country, and we've risen to challenges before. I have no doubt that we will be able to do it in this time, but we should not take it for granted. We have no natural birthright that means we'll be at the forefront of this if we don't up our game to respond to people who would love to take our place.
Thank you. So the final question, and maybe we just have a short sort of answer, is we're here at Kresge, MIT's main auditorium. All 5 of you are MIT graduates, either from the AeroAstro department or SDM. And what does it mean to you personally to be back here today to celebrate, you know, the last 50 years and the next?
It's great. Don't have to worry about problem sets or quizzes.
I would just say, don't throw out your notes. You'll use them for a long time. You're getting a lot of tool sets that you'll use.
I would say join the AIAA or some equivalent professional organization. I joined the AIAA in the student chapter here. I know that for many of us on this stage, it has been a pivotal part of our careers, right? That you typically work for receive several different paychecks over the time of your career, but a professional society can be an incredible career home and an anchor for you. And I highly recommend it for every student. So.
And as always, it's awesome to be back. I'll just say that MIT is our largest source of new hires at JPL. If you'd like a job, come talk to me.
No, it's great for me to be back, and I get back here pretty regularly. But just, you know, seeing the folks on the stage earlier today, and frankly, you know, so these are my heroes. And honestly, looking around the audience and the folks here on the stage are people that inspired me when I was here. And so I'll just put a challenge out there. You know, the folks who are, you know, on the fence about being in the space world, it is awesome. And we're looking to you to win that contest. We're looking to you to create those new companies, and we're looking to you to be up here talking about your great accomplishments in not too many years, hopefully very soon. So thank you.
Great, thank you, Keoki. So with that, I would want to thank our panelists for really an insightful discussion into the future of the space enterprise. Gentlemen, good luck with your projects, also to you personally. And I know that many of our students that are here today are eager to work with your organizations in the future. So with that, talking about the students, we will now have a break. We'll have student lightning talks after a 15-minute break. So please join us again in 15 minutes. Thank you.
Good.